My name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and today's webinar is on the topic of graphene and thermal management. Graphene has incredibly high thermal conductivity characteristics, and that makes it an interesting candidate for use in thermal management applications. We're going to hear about that today from Global Graphene Group, one of our corporate members that we're very pleased to work together with. Before we get into the presentation, I just want to tell you a little bit about the Graphene Council. Many of you are members of the Graphene Council, some of you are not. The Graphene Council was formed in 2013 as a trade body for the global graphene sector, and we represent the entire value chain from raw materials, that's graphite miners, for example, to graphene producers, intermediaries, people who are doing value add, compounders, resin system suppliers, and end users, including very large OEMs, as part of the Graphene Council. And through our partnerships with organizations like the Society for Plastics Engineers, the American Composite Manufacturers Association, the Society for Specialist Protective Coatings, and many, many others, we reach literally hundreds of thousands of engineers that are working with advanced materials around the world. And here's just a list of some of our corporate members, as well as university members. We're very pleased to have the University of Manchester as one of our university member organizations, Warwick University also in the UK, Drexel University here in the United States, and the Utah Advanced Manufacturing Initiative out of Utah is another one of our partners. And so you see, by being part of the Graphene Council, you get into really the global entire ecosystem dealing with graphene, and we think that's a great advantage of our organization. So now I'd like to change. We're going to go to our Global Graphene Group presenters. We're going to be listening today to Matthew Wang and Nathan Holliday, who are going to talk about graphene enhanced thermal management solutions.
Well, thank you everyone for taking your time out of your day to join us on this Graphene Council webinar. As Terrence mentioned, Dr. Matthew Wang and myself will be giving a presentation on how graphene enhanced thermal management solutions are changing the game. During this presentation, we're going to discuss a little bit about how thermal management is a challenge for many products, including consumer electronics, batteries, LED lighting, and more. Global Graphene Group, we are a leader in the graphene industry, developing and manufacturing game-changing graphene-enhanced products. And we would just like to note that we were the world's first company to mass manufacture graphene-enhanced thermal management materials. As Terrence mentioned earlier, we will discuss how graphene-enhanced thermal management solutions allow for heat dissipation, specific thermal management products available today, including graphene-based heat spreaders, compressive graphene foams, and then also some case studies on thermal management solutions and the outcomes. So let me go ahead and give a little bit of background about Matthew and myself. Dr. Matthew Wang has almost over 10 years of experience in developing graphene-based products, has a PhD degree in materials science from Peking University, and he joined Global Graphene Group right after graduation about 10 years ago. So he is currently the product development manager for our team, and he was also one of his main focused areas in the past years has been developing two key products of ours, our AT1500 thermal heat spreader that offers superior in-plane thermal conductivity, and then also our AT1100, which offers thermal interface materials with excellent compressibility. And then myself, I'm the technical sales manager. I have almost 7 years of experience in composites and coatings, hold the master's degree in materials engineering, and also I joined Global Graphene Group back in 2017 and helped with our sales team to help drive our thermal management solutions for our thermal films, our composites, and also other areas in terms of paints and coatings and graphene composite master batches. So let me go ahead and give a little bit of an introduction about Global Graphene Group. Back in 2002, our co-founders, Dr. Bo Zhang, filed the first ever patent on graphene back in 2002. And then Dr. Bo Zhang and Dr. Aruna Zamir, they founded Angstrom Materials in 2007. And in 2012, we were the world's first graphene mass production and then moving over to 2014 ISO certification, and then in 2016 we then joined and developed a new holding company of Global Graphene Group, and then moving over to 2017 of our silicon anode production, and leading over to 2019 in terms of REACH certification. So this is just some of our accomplishments within the last 17 years of our journey. So in Global Graphene Group, we hold almost over 438 plus patents granted. We have roughly about 90 employees currently. 48% of those employees have graduates. We produce over 200 metric tons per year of single layer graphene oxide. We recently have formed 6 joint development agreements with 5 partners in the last 12 months. We have one location with 3 facilities here in the United States, and 6 locations with 7 facilities in the Asia Pacific. And so over to the right hand side is just some of our key attributes, tailoring our patents, scaling ability, and a wide variety of product offerings, and industry leader of consumer base. So on this slide, our business is focused in 2 different areas, one being battery technologies, and then the other one being engineered solutions. So on the left-hand side is where we have battery components for the EV market that improve battery life, storage capacity, improve EV driving range, and then fast charge capability. So this is actually our near-term focus. On the right-hand side is our engineered solutions, where we take graphene and put it into various products, such as coatings, composites, thermal management materials, biomaterials, and so on, and also our powders. And I'm going to now give the presentation over to Dr. Matthew Wang to discuss our thermal management products.
Okay, thank you, Nathan, and thank you for introducing me. And thank you very much, Terrence, for giving us an opportunity to present Global Graphene Group to the audience. And I think, in the past, Graphene Council has achieved a lot of great webinars in the past, and we are honored to be able to present in this platform. So as Nathan mentioned, that we are the pioneer of graphene producer, and so one of the areas we focus on is to develop a graphene for thermal management solutions. So I will start right now. So as we all know that electronics basically is in our daily life. So we hold a cell phone, we use computers, we watch TVs, and even sometimes toys and tools. And soon we're going to be using electrical vehicles. So our daily life is very heavily rely on electronics, but electronics it's operated based on the chips and the CPUs, and with the functionality goes more and more, so the electronics becomes more powerful. And when it's become more powerful, then it will have some overheating problems. Like in the picture, we show that CPU basically is burning when it's running. So that came with some thermal management challenges. Based on studies, 55% of the electronic failures are related to overheating issues. And recently, the 5G technology is booming, and higher speed transmission of data, and also related to more heat. So all these technologies are requiring better thermal management solutions. And with EV, the thermal management solutions are related to safety issues. So we want to offer as much or as better thermal management solution as possible to all face these challenges. Graphene is the pioneer in graphene. Global Graphene Group is a pioneer on graphene production. And as you guys already well know that there are many graphene types, from pristine graphene, field layer graphene, and field layer graphite, even graphene oxide, and the reduced graphene oxide. So Global Graphene Group is capable of producing all type of graphene in mass production. So because of the strengths we have, now we are able to develop many technologies based on this. And let me explain that why we think graphene is a very good or the best candidate for thermal management. As you know that graphene is isotropic material. So in the XY plane, it has a very strong covalent binding. So theoretically, it has the highest thermal conductivity property, which is 5,300 watts per meter per K. It has been proved by the researchers. However, in the Z direction, it only offers 2 to 3 watts per meter per K range. And the reason it has such a high thermal conductivity in the XY plane, because in pristine graphene, the dominant is the phonons, and so this will help with the transfer of heat from one area to the other area. Compared to copper, you can see that it's only 400 watts per meter per K, and theoretically, graphene can offer even almost 10 times of that of copper. But theoretically is one value, and actual practical use is another. So when we use graphene, you have to consider about the vacancies, the defects, and also green boundaries of graphene. So when we connect all graphene together, then normally offer the best 2,000 watts per meter per K. So people will expect 5,000 watts per meter per K, but in actual we can get as close as 2,000 watts per meter per K. So in the past many years, the global graphene have focused on many technologies, and so because it's the high thermal conductivity, and the inventor of graphene, our CEO, Professor Bourdieu, filed the first patent on graphene heat spreader for electronics back in 2007. And since then, we put a lot of efforts in the development of products. So we have a series of thermal management solutions right now. So one of our key products is AT1500. So this film was developed specifically for 5G technologies. Because we know that in the future 5G is going to be the dominant technology for cell phones, electronics, and the transmission communications. So we start early to develop something that's different with the traditional product. So it is a dense film, and the density is around 2.0 minus plus 0.2 grams per cubic centimeter. So it offers 12 to 15 watts per meter per K in plane thermal conductivity. And G3 has standard products range from 40 microns to 100 microns in mass production. And we can also customize different thickness beyond 100 microns. For example, 150 microns, 200 microns, 300 microns. Even higher, it depends on your requirements. So they can be put into cell phones, large screen displays, LED lighting, and to dissipate heat. And we have shown the superior properties of such products. Like in the left of this slide, that's our standard products. And our strength is we can keep the same thermal conductive value from 12 to 1500 watts per meter per K in the range of 40 microns to 100 microns. So that's something that the competitors cannot achieve. If they increase the thickness, they will sacrifice for the thermal conductivity. So that's something that G3 is really focused on to offer better thermal conductivity while maintaining the higher thickness. And on the right of this slide, you can see how good the performance of AT1500 comparing to other heat spreaders. So in this slide, I would like to show a video and to compare and how effective our AT1500 to dissipate heat. So if we only show the heater, and you can see that with few seconds of heating, the temperature go up really quickly to about over 150 degrees Celsius. So this is just show you, because the limitation of the IR camera, you can see that 150 degrees Celsius, but I assume it's much higher. So with AT1500 50 micron heat spreader, and you can see how effective it is to dissipate the heat. It reduced the temperature dramatically from over 150 degrees Celsius down to close to 17 degrees Celsius. That's basically reduced half of the temperature level. And you can also see that from spot 1 to spot 2, and the uniformity of the heat spreader. So that's not only lower the heat source, but also dissipate the heat to the surroundings. If we further increase the thickness of heat spreader, in here we offer like AT1500 100 microns, and you can see this also further reduce the temperature level from 70 degrees C to close 50 degrees C, and also it's dissipate the heat to the surroundings from spot 1 to spot 2. You can compare. The difference of temperature is only less than 20 degrees C. Yeah, the video is last about 2 minutes, so I will show you start to the next slide. But the last slide just want to tell you that it's very effective when you increase the thickness while maintaining the same thermal conductivity level. And this is actual example that we put our AT1500 into laptops, and without AT1500, and you can see that the temperature can go as high as 58.3 degrees Celsius. With our 1500 heat spreader, it dropped about 10 degrees Celsius, which is very effective on heat dissipation. Definitely keep the laptop cooler. So another key product is AT1100 we have developed in the past years. And in the opposite of AT1500, AT1100 is a low density thermal film. So it was developed is targeting the thermal interface applications. So it offers low thermal resistance and can give you option that in the through plane dissipation of heat from the heat source to a heat sink. We can offer 70 microns, 100 microns, 200 microns to 300 microns. So such film is also very stable. We use graphene as the raw material. Graphene is one type of carbon or graphite material. It's quite stable, so it can withstand minus 40 degrees Celsius to 400 degrees Celsius. In this slide, we just want to show the audience that the way how to use it from a heat source to the heat sink, and under different compressed pressure, and it offers very low thermal resistance. And we also did some study on the stability of such film under different circumstances. For example, high temperature, low temperature, temperature shock. This film still maintain intact and keep the same performance as it is in room temperature. And expect to these two key products we have developed, we also put graphene in many forms. For example, for thermal interface materials, we not only have AT1100, which is very easy to put into a gap and easy to handle. We also, offer traditional graphene thermal paste. So we put graphene into the paste material, and we can achieve a product that offers 2 to 10 watts per meter per K thermal conductivity level. And it's also easy to be used, replaced. And we offer in different packages with small amounts of quantity, like in the syringe forms, or we can offer in the bucket forms, with kgs of material. And in this one, I want to show how our graphene thermal paste performs and why it is better than traditional thermal paste. As you know that normally people put semiconductive fillers into the thermal paste, and graphene is one of them. But the advantage of graphene is it's a 2D nanomaterials, so it's smaller in size, and so it can fit in any gaps or void could happen between the heat source and the heat sink. So it offers better contact, and then it offers lower thermal resistance. And this is a structure that we investigated with our thermal paste, and you can see that it's very effective. And also we compare with the low temperature performance as well, and shows that even at minus 40 degrees C, it still performs as it is in the room temperature. And we also put graphene into epoxy resin to develop a product called the thermal paint. So this is a very useful solution for any enclosures or heat sinks. So you just simply spray or dip coating this product on your enclosures, and you can offer better thermal dissipation properties. As you can see in the slides on the right, that we spray such paint onto the LED light casings, and you can see how effective it is to make the LED light cooler. It's about 14 degrees C difference. And I think people know that the importance of temperature for the LED life. So with 1 degree C of difference, LED life can, probably double. So graphene is very effective on this. And as I just mentioned, that you can simply just use spray coating techniques or dip coating techniques to put onto your surfaces or heat sinks. And we can also offer different quantities. We also put graphene into many polymer materials to make a graphene composite. So this is an example to you guys that we put graphene into our ABS PC composite at a different percentage of graphene content, and we investigated how effective it is to dissipate heat. As you can see in this slide, that with higher percentage of graphene, the thermal dissipation improves better, and we can reduce temperature from 85 degrees C all the way to 65 degrees C. So that's about 20 degrees C difference. And so this is very effective of graphene in the composite form. So with the performance we have shown to you, and we think that the graphene composites or graphene mass batches can be used as casings or enclosures for many products. For example, the VRs, laptops, projectors, and all LED lights, anything that electronics has, and you can replace it with graphene composites and offer a better heat dissipation and keep your device cooler. And we can also see that the trending of the EV cars, and I think graphene composite can replace some of the parts, not only offer better heat dissipation properties, but also can be lightweight. Because when we do the investigation, we found that not only graphene can offer better thermal conductivity, it can offer some improvements for the mechanical strengths. So you can use lighter cases or lighter parts with graphene composites. We also investigate our graphene on the applications of graphene rubber composites and for tire applications. In this slide, you can see the structure of a typical tire, and we put graphene into different parts. And so graphene can offer, for example, for the interior layers, and graphene can offer air barrier properties, because we know that the graphene is a hexagon structure and it's very keep in place and can reduce all possible airs to penetrate inside. And also we observed that the mechanical strength improvements as well. And for the outer layer, then the strength of the tires, it definitely can help with the thermal conductivity and also can help with the anti-static issues. And so in this slide, we want to show you that graphene does improve the thermal conductivity of rubbers. And so with the different contents of graphene, the thermal conductivity of the rubber improves from 0.3 to 0.9, which is 3 times better than the pure rubber materials. It's very effective. And so in addition to that, as I mentioned, it can offer improvements on the anti-static performances. So we can reduce the electric resistance of rubber down to 10 to the 3 to 10 to the 5th ohm per square with different amounts of graphene. And also with only 0.3% of graphene, we can see very low permeability of the air. So can effectively reduce 48% of air penetration, which is very significant. In the end, we also want to mention that other property of graphene can offer. As you know, that single layer graphene are transparent. So one layer of graphene only blocks about 2% of light. So then with this property or unique characteristics, and we try to use graphene as a transparent conductive layer for many devices. In this slide, we give you an example that on a window or smart window application, possibly, like before you charge it or before you put the electricity in there, it's like a haze, non-clear sheet. But when you apply electricity, you can see that it's transparent. So that's basically use the conductivity, electrical conductivity of graphene to perform like this. And we also combine the graphene with silver nanowire to protect silver nanowire will improve the electrical conductivity tremendously. And with this, in the opposite of dissipating heat, with graphene and silver nanowire, we can even heat it up as a resistor to offer some type of a heat. So this is just an example that despite the thermal management solutions, there's other different aspects of graphene can be used too. And here we have a little example to show to you guys, and hopefully it can play. So yeah, in summary, we just want to tell the world that Global Graphene Group is the pioneer using graphene for thermal management solutions. And we not only offer heat spreaders to dissipate in the X1D plane, we also offer some interface materials or even materials placed on the surface of your devices. So it's like an entire solution. In many different cases, you can consider graphene thermal management products. So I will go back to Terence, and for people, if any questions asked, we can possibly answer for you or share our comments with you guys. Thank you very much.
Well, Dr. Wang and Nathan, thank you both very much. This is very interesting, and I encourage everybody to stay on because we have quite a few questions and some really interesting questions for you. So the first one is asking, does the high electrical conductivity of graphene become an issue for some applications, such as in EVs? So how do you address that issue? So that's an interesting one. With the thermal management, you also have electrical conductivity with graphene. How is that managed?
So the electrical conductivity of graphene is like a double-edged sword. So in some applications, people will require, okay, you have electrical conductivity, that's great. So we can use it as the EMI shading opportunity as well. And then or like grounding, that you can just cover it up our devices, but also can connect to the ground and avoid any electrical short. So that's we can see from using the electrical conductivity as an advantage. Well, to do the thermal management. But on the other hand, that if the areas that really don't want to see any electrical conductivity to have a failure on their devices, and normally people will do our lamination of this heat spreader into an envelope shape, basically covered up with a double-sided adhesive and one insulating layer. For example, for cell phones, and then people normally will have an envelope structure to avoid the electrical conductivity issues. Does that answer?
Yeah, I think so. I think that gave a great answer. So in summary, in some cases, it's actually an advantage to have the electrical conductivity. And in other cases, then you use it in combination with an insulator. Another question.
That's correct.
Another question that we have is the AT1500 product. How does that compare to a standard graphite foil? So there's a lot of standardized heat spreader materials, graphite foils. How would you characterize how they compare with the AT1500 product that you displayed?
Yeah, that's a great question, and thanks for asking that. So, like I mentioned in the presentation, that we developed this product. It's targeting 5G technologies and targeting high power to electronics and higher heat dissipation issues. That's why we developed this product, because we see that the current product using traditional graphite sheets or synthetic graphite sheets cannot offer or is not enough. And so we know that for the standard synthetic graphite sheet, it can only offer certain thickness, for example, 20 microns or even 40 microns. And if they want to go higher in thickness or have more heat flux, they either stack them in different layers. For example, from 20 microns to 70 microns, then they will stack 3 layers of 20 micron products, and they put 5 micron adhesive tape in between, so they can have, can dissipate more heat.
Right.
But the issue is, if they use 5 micron adhesive tape, that offers heat resistance. So make the heat dissipation path is less smooth, and sometimes it's a resistance, so not as effective. But for our AT1500, we don't have these issues.
Right.
So we increase the thickness, but at the same time, we don't introduce any resistant, thermally resistant layers to it. So that not only have higher thermal conductivity, but it can also quickly dissipate more heat compared to current synthetic graphite sheets.
Right, and I think we saw that in one of the slides where you show, we don't need to go back to the slide now, but in one of those slides you showed the different levels, 20, 40, 50, 100 microns, and the consistency and the thermal transfer there, as well as in the video with the FLIR images of showing how that dissipated with different thicknesses. Now, there's another question here that I think is going to be related and is quite an interesting one specifically for graphene, because as you've demonstrated and we know, the in-plane thermal conductivity is quite high, but there are many applications that require through-plane or z-axis thermal transfer. So how is that addressed in those cases where you need just not in-plane but also through-plane thermal transfer?
For the through-plane, that right now, like we introduced to the audience, that we can offer the AT1100 and also the thermal paste. So this product is targeting on the through-plane, and we think that for traditionally the through-plane thermal conductivity requirements, it's basically they want to lower the resistance between the heat source and the heat sink. So both of these two products, AT1100 and our thermal paste, can perform very low thermal resistance. Then you can better dissipate the heat to the Z direction. And but if the requirements for thermal conductivity is even higher than what we have right now, for example, they want asking for like 100 watts per meter per K, and there will gonna be totally a different products that graphene can offer. And Global Graphene Group, it's working on that, but we are not ready to just launch it to the audience yet. But like I said, the in-plane is high. Is there a way to do a rearrangement? Then you can achieve a higher on the Z direction.
Got it. Okay. Thank you for that. It was interesting that you, sorry, go ahead.
Oh, no problem. Thank you.
So you introduced some of your product in composites, and it was interesting because you were approaching it from the thermal management side, although of course, and we've talked about this a lot, about the advantage of graphene is it imparts other beneficial characteristics such as added strength and lightweighting. There's a question here that, for example, if you had a battery cell housing piece that was made out of a molded graphene enhanced composite, does the graphene change the ability to weld, either using like an ultrasonic welding process? Does it change the way the materials can be molded together? Do you have any experience with them?
Okay, I can answer that to an extent, because when we develop many types of composite materials with graphene, we have put graphene into many systems of polymers. So graphene offer mechanical, electrical, and thermal, but we don't observe really, structural or performance change of the base material.
Right.
So the property of the base material is still there. So if you use a welding technique or binding techniques, I don't think that will affect or change that side of performance of the base material. So I wouldn't think it's going to be an issue.
Yeah, from our side, from the Graphene Council, we've not heard of that aspect at all. It's not been brought to our attention that it degrades the ability to engineer or work with the materials, and so we just haven't heard that. A straightforward question, just for a comparison, because we're looking at putting graphene, and this is graphene into tires or into these rubber products, which is becoming quite widespread, primarily to improve the performance on traction and wear. But again, you showed there's this added benefit of heat dissipation, which is important for the performance of the product under load. What is the normal loading of carbon black in tires as a percentage, roughly?
Well, I can answer, but I don't know whether that's a very quite accurate answer. So as far as we know, that it's probably around 20% or above of carbon black. Yeah.
Yeah, my understanding is it can be as high as like a 30-35%.
Yeah, it's 30, even 40. Yeah,
yeah.
We think that's possible.
Right. Another question came through. The surface chemical inertness of graphene, it doesn't react, makes it difficult to be modified. Is it immiscible in polymer matrices, becoming a big issue with long-term storage? And we have another question regarding functionalization chemistry in the case of with nanowires. I know those are two very, very different applications, but can you talk a little bit about the need for functionalization? We just did a webinar on Tuesday this week about graphene and composites, and a testing program we're going to be doing about how graphene performs in a base resin. So what about dispersion and reaction and functionalization? If you could cover those several topics. I know they're quite different, but they're somewhat related.
Yeah, of course. And Nathan can answer that for you.
Yeah, Terrence, so we do have the capability to functionalize our graphene on many different functional groups, some specifically being carboxyl or amino functional groups. So we do have that capability. And in terms of dispersion, I mean, we do it in a variety of different ways in terms of composites and also paint and coatings. So the way that we do that is basically the customer sends us their overall base material, whether if it's a composite or whether if it's an overall liquid dispersion, and we'll use our overall patented mixing processes to incorporate graphene into there, and then we'll send it back as a master batch or as a graphene enhanced dispersion. The reason we do this is because when we originally first started back in 2007, we were originally sending just our powder materials to our customers. But then when we reached out to them and asked for feedback to see how everything was going on, a lot of the customers had a very difficult time dispersing the material.
Right.
So we asked them how they would disperse their material, and they said they did it this way. We offered some technical advice, and so then therefore we went ahead and we developed our graphene nano intermediates technology, which is basically, as I mentioned, they send us the polymer resin, we'll incorporate the graphene, we'll send it back, and it even helps the customer out because they don't want to deal with the messiness and the work exposure to dust of graphene. So we'll go ahead and we'll take that off your hands and send it back to you, and then you can add it into your commercial product without even adding any extra processing steps and everything. So we as a group, once we determine all of their application development requirements, we sit down as a team, talk about what graphene type we use and which concentration we should use, and we'll send it back to you. So we try to make it high tech and also low cost for the customer.
Yeah, that's exactly for the composite. As you guys know, that our co-founders, Dr. Jiang and Dr. Rajamu, they have tremendous of experience of developing all types of graphene. As I show you in the slides, G3 offer many types of graphene. So functionalization is, we have a lot of experience. Our pioneers have deal with that with many customers. So functionalization is, like Nathan said, there's no issue, and we can help customers to achieve what they need.
Well, it is a common theme in what we've seen. The most successful applications has been where the customer works closely with a graphene producer, graphene formulator. And as you mentioned, the advantages of not having to deal with a nanopowder, the dispersion technology or the dispersion expertise is almost as important as the material itself for it to hit the performance marks. And so I think that's a really important point. I know that we have people, sorry, go ahead, Nathan.
Terrence, to add to that, I mean, I would just like to say that we incorporate the graphene in many different ways. 3 ways, for example, one being where the customer sends us a polymer epoxy liquid resin. We'll incorporate the graphene, send it back to you. Our graphene can also be dispersed into various solvents that can be directly added into the commercial product. Or as a composite application, we incorporate the graphene into many different polymer-based resins for thermoplastics, and then we'll send it back as a master batch. So we do it in a variety of different ways.
Excellent. Thank you. We have another question on how you would compare graphene with boron nitride in terms of thermal conductivity in a polymer, either on cost or performance.
We know boron nitride is one of the candidates for the thermal paste. It's really in the range of, I think, 40 to 70 watts per meter per K value. And so those are ceramics, and I think they are the size of larger than graphene. So we have many types of graphene from not only single layer graphene, which is our premium product, but we can also offer the field layer of graphene can offer like even 300 watts per meter per K intrinsic thermal properties, and better than boron nitride, I guess.
Excellent. Thank you.
Yeah.
Another question, and we have seen this where we know the companies are spinning graphene enhanced polymers into fibers and into yarns. But the question is it yet possible to create a graphene yarn for sportswear and textile materials? And that again would be strength, feel, thermal transfer. What's your take on that? I know there's another company, I won't mention the name, that focuses a lot on textile applications. But what's your experience with that?
So yeah, we've had a variety of different experiences, and our main experience, what we've had, is where the customer sends us They offer it in an overall plastic form, which is either a bead or a pellet type of form of the base polymer resin material.
Hmm.
And we'll incorporate it in, we'll send it back as a master batch. So that's our graphene composite master batch solution right there. Another one is based on their overall process. We have, as I mentioned before, graphene dispersed into various solvents. We've also dispersed graphene to various mineral oils. So as I've mentioned before, there's a variety of different ways, and we have the expertise and the graphene technology to do that for our customers, and we've been successful. And when PhD doctors say it doesn't work, G Cubed actually provides the solutions.
Right. Thank you.
Yeah. To add on that, about the yarn or fibers, and I think if people you are interested, we have brochure on the graphene composite, and you can look into our brochure, and there will be a page that's showing that we have graphene nylon put in a fiber roll. Yeah, you can take a look at that, and
And specifically speaking to that graphene nylon fiber, we have seen with a couple of our customers where graphene has enhanced the nylon fiber mechanical strength by over 100%.
Yeah, absolutely. We've received that kind of feedback from other producers as well, that they've seen some really significant, I would say in excess of the 100 even, several times improved with the PA6 material. I'm going to ask one more technical question, and then I have a short bit to sign off for today. And I want to thank everybody for all the questions. I know we're not going to get to all of them, but there's another question regarding the compatibility of graphene with acrylic polyols, and if it's being considered to be added to paint, for example. And we know that there are applications of there are several companies that have been working with graphene enhanced paints for anti-corrosion properties. Let me add on to the question here. In the presentation we did on Tuesday, we were basically looking at the traditional plastics pyramid. Are there materials that you found that graphene cannot be added to? Maybe the easier question.
To be honest, as I mentioned before, when we talk with one of our customers, we ask them a wide variety of application developments based on their needs and their expectations. And then from there, us as a team, we sit down internally to determine which of our graphene products will work best for their application and their needs, and what's the best concentration. So that's one point. The second point is, in terms of anti-corrosion, we have a lot of experience with that, specifically referring to metal-rich coatings and also polymeric coatings. So on metal-rich coatings, just let me speak on behalf of that real quick. A commercial coating is basically a commercial metal-rich epoxy primer is about 70 to 90% zinc dust. Offers very, very good corrosion resistance, very good mechanical strength. However, over time, the mechanical strength in the adhesion tends to decrease. So what we did is we did some research where we actually reduced the zinc dust by almost 70% and incorporated the graphene to not only enhance the mechanical strength and adhesion, but also enhance the electrical conductivity to offer enhanced electrical conductivity, but an additional sacrificial protection barrier mechanism for the zinc-rich epoxy primer. One application for that is basically being bridges. And so the research that we've done is we've actually ran our graphene enhanced metal-rich zinc-rich epoxy primer compared to a commercial one using 3,500 hours in salt spray solution, and it is very, very successful. And also another thing to note to that is that by reducing the zinc dust, customers are also reducing the cost of zinc dust since it's very, very high. The second point in terms of switching gears to polymeric coatings is that, as I mentioned before, we can incorporate graphene into various liquid resins, being epoxy, acrylics, polyurethanes, etc. And so we've incorporated graphene to those various liquid polymer resins, but we've also seen in terms of a larger scale that we can offer is incorporating graphene into various solvents that is within their commercial coating of epoxy, polyurethane, or acrylics. So we can do it as I keep mentioning, a variety of many different ways. We really focus on the application development part in terms of understanding the customer, what their needs are, and what their expectations are.
Excellent. Thank you so much for that. Let me conclude. I do want to just share one more thing with the audience before we sign off today. And as I do that, I want to just say thank you to G3 for being a part of the Graphene Council. And thank you for an excellent presentation about graphene and thermal management. For those of you who are not a member of the Graphene Council and are not that familiar with us, we've just recently released a report on the graphene production processes, characterization techniques, commercially available forms of the material, market pricing data, standardization applications, and profiling nearly 200 graphene producers worldwide. It is the most comprehensive report available on the market today, and that's part of membership in the Graphene Council for our corporate, enterprise, and university members. And just to encourage you to think about the Graphene Council and becoming a member, that's our commercial for today, to receive benefits of weekly graphene intelligence. And I can tell you every week we have news from G3 because they are very prolific on the patent front, and they're one of the most, the deepest benches, if you will, in terms of graphene manufacture and application development, having many years in this field, which is still quite young. But we really value them being part of this and appreciate their contribution to today's conversation. So with that, as the Executive Director of the Graphene Council, I want to thank everybody for your participation today and encourage you, if you're not a member of the Graphene Council, to join. And if you are a member of the Graphene Council, we want to thank you for being that. And we are continuing to add value to our community as we help to commercialize this amazing material, which just from today's presentation and focusing just on thermal management, we see it has so many different applications. And with that, I want to say again, thank you to everybody. Appreciate you participating today. Have a good day.